Alright, so this should be pretty short. This is just a wrap-up. Remember that after each chapter we do a review and then a test. So this is just to sort of review all of the things we learned. So one of the most important and guiding things in everything that we do are that whenever you have an equation, what it's really saying is that two things are equal. So in the first example here, we have x plus y equals 3. That means every time you see x plus y, you're allowed to think 3 instead. Or anytime you see 3, you're allowed to think x plus y instead. And that's because the two are equal. Down here we have y is equal to x squared minus 4x plus 5. So anytime you see y, it's the same thing as x squared minus 4x plus 5. So that's one of the most important guiding things in the entire chapter that helps us manipulate equations so that we can get solutions to them. So what's a solution then? Well, a solution to an equation is an assignment of values to the variables so that the equation is true. So in the equation x plus y equals 3, if we let x be 2 and y be 1, it becomes a true assignment of values because 2 plus 1 does equal 3. So this is correct. It is a solution to the equation, and we write it, we almost always write our solutions as ordered pairs. The x value going here, and the y value going there. Another example is to take the equation y equals x squared minus 4x plus 5, and we can ask is, let's see, for 0 a solution? Well, remember, in for 0, this is my x value and this is my y value. And so if we replace all of the y's and all of the x's up in that equation, we get 0 equals 4 squared minus 4 times 4 plus 5. And if we do a little bit of reduction, 16 minus 16 plus 5, and we're left with 0 equals 5, well, that's false. It's not okay. And so it's no, it's not a solution. So remember, equations have solutions, and solutions just represent an assignment of values to the variables that make our equation true. So this chapter is called System of Equations, and what that is it's just one or more equations with the same variables. So for example, x plus y equals 3, and 2x minus 5 equals y. So these are two equations. Here's equation 1, here's equation 2, and they have some of the same variables appearing in both. In fact, they have all of the same variables appearing in both. So what we were dealing with is ways of finding the solution if you have a system of equations. So what were the ways of doing that? Way 1 was graph. So for example, if we have the equations y equals negative x plus 4 and y equals 2x minus 2, and we graph them, quickly throw up a set of axes. So y equals negative x plus 4, 1, 2, 3, 4, starts here and has a slope of negative 1. And so if we draw some points and then connect them with a line, we get our first equation's graph. Here's the graph for 1. And y equals 2x minus 2, that crosses down here at negative 2 and has a slope of 2. And we go ahead and draw our line, and we can see right away they cross here. Where is here? Here is the point 2 comma 2. And you can check. Negative 2 plus 4 does equal 2. And so that's the check for equation 1. And the check for equation 2 is that 2 equals 2 times 2 minus 2. And so they both check out just fine. So graphing's fine, except it's messy, it takes a lot of time, and it's not the best. And so the next thing we learned was substitution. And you cannot forget substitution, because it comes back up in the word problems, it comes back up in things we're going to do later. And so this says, when two things are equal, one can be used in place of the other. So for example, if you have x equals y plus 3, and then you have another equation involving x. So for example, y equals x squared. Anytime you see x, like here, we can replace it with y plus 3 here. And so an example of substituting is replacing the x with y plus 3, like that. So this is a totally valid use of substitution. We said, anytime I see one thing, I can replace it with the other. Our examples are a little bit nicer. We have things that look like y equals 2x minus 2, and y equals negative x plus 4. Remember, this is our example from back here. But we're going to use substitution to solve it. Let's go ahead and use this to replace that y. So that y is going to be replaced with 2x minus 2. And we get 2x minus 2 equals negative x plus 4. And the one thing you should notice about substitution is after you've substituted, there's only one variable left. And that gives us much hope for being able to solve for that variable. So we're going to add 2 to both sides and get 2x equals negative x plus 6. Add x to both sides, and then get 3x equals 6. And then divide both sides by 3. And that gives us that x equals 2. Now, we're not done. Remember, when we're talking about a solution, it's an assignment of values to all of the variables. Let me go ahead and add that word up here. All of the variables need something so that we're true. And we only found a solution for x. So to figure out what y has to be, we just plug x into one of our two equations. So if we do y equals 2 times x minus 2, right, that's our first equation. We're going to check down here. That means y equals 4 minus 2, or y equals 2. And so our solution is 2 comma 2. And there's our answer. So substitution works wonders. Elimination is our next one. What elimination said was if you have two equations, you can add them to make a third, also valid equation. And so our example of that is to take something like 2x minus y equals 5 and 3x plus y equals 10. And if we add our equations, we get 2x plus 3x is 5x, y take away y is 0 equals 10. Oh, sorry, equals 15. And if we divide both sides by 5, then we get that x is 3. So down here we get x is 3. And now we still have to take that 3, plug it back into one of our equations to get y. 3 times 3 plus y equals 10. 9 plus y equals 10. Subtract 9 from both sides. And what do we get? We get that y equals 1. And remember that we always like our answer written as an ordered pair, and so we get 3, 1. And so that was elimination. So we have graphing, substitution, and elimination. The last thing we did was word problems. Okay, so here is your normal, I'm going to freak out word problem, right? You see a word problem, all of a sudden the idea that you remember how to do math just drops out of your head. And I'm here to tell you that it doesn't have to be. So, reading the problem, Joe is 3 times older than Susan. In 2 years, he will be twice as old as Susan. So how old are they now? So there's a bunch of things we have to figure out here. One is how to translate the sentences into math. But before we even get started, we need variables, right? So remember, step 1 is always make variables. Like an E. So x is going to be Joe's age, and y will be Susan's age. And so let's look at the sentence, Joe is 3 times older than Susan. When I am looking at this sentence, what I'm seeing, Joe is, and that's the same as Joe's age, Joe is x, is means equal. 3 times older is 3 times than Susan, y. So I see the equation x equals 3y. Now, how about in the next one? In 2 years, he will be twice as old as Susan. So if Joe is x years old now, 2 years from now, he's going to be x plus 2. So x plus 2 is what his age is in 2 years. Susan's is also x, is y plus 2. Right, but Joe's age, which is x plus 2, will be twice Susan's, which is y plus 2. 2 times y plus 2. And will be is another word for is, and so that is where our equals is. And so look at my two equations. I have x equals 3y, and I have x plus 2 equals 2 times y plus 2. Now, your brain should be working here saying, this is just a system of equations. It's the chapter we're in. And this top equation, to me, screams, use substitution. Instead of writing x, write 3y. Right? And here's the x, and it's going to become 3y. 3y plus 2 equals, now, 2y plus 2, we need to distribute. That becomes 2y plus 4. Move the 2y, and we get y plus 2 equals 4. Move the 2, and we get y equals 2. Now look, that's Susan's age, right? Susan's age is 2. So how old is Joe? Well, look at the equation x equals 3y. That's going to help us, isn't it? We can plug this in, and we get x equals 3 times 2, and so x equals 6. And so Joe is 6, and Susan is 2. And that makes sense, right? 6 is 3 times 2, and 2 years from now, they'll be 8 and 4, and 8 is twice 4. So there's an example word problem. It can be solved using substitution instead of the elimination that the word problems usually look like. And that's it. This is the wrap-up of the chapter. Go ahead, study for the test, and I will see you in class.